In this video, we're going to talk about the solutions of the Grade 12 IB Math September tutorial problem set. Question 1. Let f of x equals e to the power of x plus 3. In part A, we are asked to show that the inverse of the function f of x is equal to ln x minus 3, and write down the domain of this inverse function. First, we interchange x and y in the original f of x equation. So you have x equals to e to the power of y plus 3. Ln both sides of the equation. This gives you a ln x equals y plus 3 ln e. Because we are allowed to bring the exponent of a power in front of the ln of that base. Simplifying, ln e, that's 1. And now we're going to isolate for y. Y plus 3 is ln x, therefore y must be ln x minus 3. Just rewriting using the inverse function notation, f negative 1 x is equal to ln x minus 3. And when it comes to the domain of this function, well, maybe it's good to review what an exponential function looks like. So f of x is e to the power of x plus 3. So this is the exponential function of base e, shifted 3 units to the left. This still gives us a shape that looks like this, is an exponential growth with a horizontal asymptote along the x-axis. So now, if we think about the inverse of this function, well, the domain will become the range, and the range will become the domain. Therefore, this graph here, or sketch here, shows a quick sketch of the function ln x minus 3, and there should be a vertical asymptote along the y-axis, telling us that the domain of this inverse function should be x is greater than 0. And then part B, we need to solve the equation of the inverse of f of x equal ln of 1 over x. So you equate ln x minus 3 and ln 1 over x. We want to gather all the like terms, or the x terms. So you have ln x minus ln 1 over x equals to positive 3. We know that when we are subtracting two ln expressions, this is equivalent to ln of x divided by 1 over x. You can also find this in your formula booklet. X divided by 1 over x is x squared. So ln x squared is equal to 3. Rewrite this in exponential form. You have x squared equals to e to the power of 3. Keeping in mind that the domain of these functions is x is greater than 0, so when I square root both sides of the equation, we can reject the negative square root. And so our final answer will be x equals to e to the power of 3 over 2. Question 2. Find the equation of the normal to the curve with equation y equals to x cubed plus 2 at the point 1, 3. So the term normal prompts us to think about the tangent of an equation, and to find the equation of a normal, we need the slope of the normal, which comes from the slope of a tangent. So that means we need to think about derivatives. Normal is the line that is perpendicular to the tangent. So if we make a quick sketch of this equation y equals to x cubed plus 2, take the x cubed function and shift it 2 units up. So right here you have a rough sketch of this. The point 1, 3 is on this function. The red line here shows the tangent at the point 1 and 3, and therefore the blue line here shows the normal to the curve at 1 and 3. Putting all these ideas together, take the first derivative of y equals to x cubed plus 2. You have 3x squared, because the derivative of plus 2 is 0. And the actual value of the slope of the tangent at x equals to 1 will require you to substitute 1 into x into 3x squared. So sub it in, you get 3. In other words, the slope of a line perpendicular to this will be the negative reciprocal. So the slope of the normal will be negative 1 over 3. So now we have a point on the normal, 1, 3. We know the slope of this normal. You can substitute these into y equals mx plus b form. This will give you a y-intercept of 3 1/3 and a final equation of y equals negative 1 over 3x plus 3 1/3. Number 3. The graph represents the function f of x, p cosine x, and p is a natural number. So this is talking about a vertically stretched cosine function, and a quick inspection does confirm that the period of this function is 2 pi, which means that the value p would simply be the amplitude of this function. As a result, the value of p is 3. B. Find the area of the shaded region. You've learned in your integration unit that to find the area shaded between the curve of a function and the x-axis will require you to take the definite integral from the beginning to the end of that region. Luckily, we only have an area that is above the x-axis, which simplifies our work greatly. So we can say the area of the shaded region is the definite integral of 3 cosine x dx from 0 to pi over 2. Either recalling from memory or using your formula booklet, the integral of cosine x is positive sine x. So 3 is just a scalar multiple, so that's why we see 3 sine x here. And now we're ready to evaluate our definite integral by first substituting pi over 2 into x. So you have 3 sine pi over 2, and then you subtract, substituting 0 into x, 3 sine 0. Without using a calculator, you may have different ways of remembering these key values of sine. One way is by looking at a sine function. So sine pi over 2 would be 1. So the first term will be 3 times 1, 3. And then minus 3 times sine 0, which is 0. So therefore, the area of the shaded region is 3 square units. Or just 3. You can leave the unit out on your exam. The next question is a linear regression question. For a question like this, when you have mass and length, sometimes it's hard to tell which variable should be your independent versus your dependent variable. So one thing that you should do on the exam is to read all the parts in your question and look for a clue. Well, in part B of the question, it says find the equation of the regression line of L on M. So L depends on M, implying that L, length, should be your dependent variable y, and M should be your independent variable x. Okay? So this is a graphing calculator question. You have to recall how you can input data. So you'll be using a stat button, enter the masses into L1, the length into L2, and then you use that calculate linear regression to come up with the equation of the line, of best fit, and also the correlation coefficient. And make sure your diagnostic function is turned on, or otherwise the correlation coefficient will not show up. So after you do all that, the correlation coefficient works out to approximately 0.801 rounded to 3 significant figures. And the equation of regression line will be L equals 4.07x plus 36.0 rounded to 3 significant figures. Question C asks you to estimate the length of a baby whose mass is 3.2 kilograms. So you just substitute 3.2 as mass, or x. Oh, I should be using m instead of x here. And then multiply that by 4.07 plus 36. That should come up to 49 centimeters. Again, rounded to 3 significant digits. Part D. Can the regression line be reliably used to estimate the length of a baby of mass 5.6 kilograms? Explain your answer. Well, if you inspect your data table, 5.6 kilograms is a mass that is greater than our maximum mass, which is 4.3. So that means this estimation will require us to do an extrapolation. Well, since we're using extrapolation, it will be less reliable using this model because we don't really know what happens after mass goes beyond 4.3 kilograms. So we can say that 5.6 kilograms is outside the domain of the given data set. Therefore, the current model would not be reliable for use in the estimation or for extrapolation. And lastly, we have a circle question. So O is the center of the circle, which has a radius of 5.4 centimeters. The area of the shaded sector, OAB, is 21.6 square centimeters. Find the length of the minor arc AB. So for questions like these, I highly recommend that you label your diagram. So the radius, the angle subtended by the arc, and also the area in the sector, that's optional. And also we need to know that the minor arc, because we only have A and B marked on the circumference, minor arc will be the shorter side. The longer arc that is connecting A and B is called a major arc. Okay, so right here we're looking for L. You just need to be familiar with your formula booklet in a lot of ways for this question. You know that there is a formula for area of a sector, which is area equals 1/2 theta times r squared. And there is a formula for calculating the length of an arc, which is theta times r. So all you have to do is to substitute the numbers correctly and carefully. This will give you an angle of 1.481 dot dot dot. Or if we want to state this intermediate answer in 3 significant figures, it will be 1.48. And then to calculate the length, you multiply the angle by r. And I will highly recommend that you use the unrounded answer. So keep that number on your calculator and then multiply that by the radius 5.4 to get the length of the minor arc, which is 8 centimeters. So this brings us to the end of the September tutorial. So we'll try again in October. Stay tuned on Google Classroom and see when the October problem set will be posted. It will be posted early on in the month, and then we'll have the tutorial probably in the last week of October. See you then.